By way of very quick introduction, Megan and Elizabeth are the 16-year-old creators of Science Rocks.
And I'm Elizabeth. We are the founders of Science Rocks, our award-winning multimedia science project that encourages people to get excited about science. We interview prominent scientists. We make award-winning films. We cover the GCSE science syllabus. We give talks at junior schools and we showcase our project at science fairs. But first, this is Science Rocks.
Hi, I'm Tim Peake, an astronaut with the European Space Agency. This is Science Rocks.
We started off by interviewing Charlotte Kenshington from Cambridge University. She's one of the leading authorities on Charnia, a type of organism based on trilateral symmetry that predates the dinosaurs by 300 million years. We've also interviewed Dr. Michael de Podesta on his research on thermometry and Dr. Ed Brightman on hydrogen fuel cells. These and other interviews can be seen on our YouTube channel and website. Here's one of our own films we made about superconductors with Dr. Simon Foster from Imperial College. We are here at the main lecture theatre in the physics department at Imperial, and we are going to be looking at superconductors with Dr. Simon Foster. But first, over to Megan for the science. This is a normal material on a magnet. As you can see, the magnetic fields pass straight through it. This is YBCO over a magnet. When YBCO is supercooled, it becomes a superconductor and repels the magnetic fields, making it float. Simon is about to supercool the YBCO and then place it on the track of magnets.
Here we go.
He's supercooling with liquid nitrogen.
So, at minus 200 degrees, I'm just pouring it in this very carefully cut polystyrene cup, as you can see here. And if we look inside, you can see the liquid nitrogen boiling as it cools down our superconductor in there. So, actually, it only takes a few seconds, so we might be in luck. We can just go straight to this. As you can see, I'm using tongs because this stuff is very cold. So let's stick it on the track and see how we get on. See it floating around until it obviously loses that one's not so good. So you can see this used to be a nice perfect disc until it broke into many different pieces, unfortunately. But these are all different magnets. They've got north-south, so it kind of it helps it float along. Look underneath. See it just, and hopefully this is how one day maglev trains will work.
Why is research into superconductors so important?
Well, there's several different elements. One of them is obviously, we've seen here, if we can make magnetic levitation a real possibility at everyday temperatures, then you could have trains to be able to shoot up and down at super fast speeds and be able to get from London to Edinburgh or London to Manchester really quick because you wouldn't have any resistance, you wouldn't need the tracks. That's one really important thing. The other thing is, obviously, when you have a superconductor, it's got no electrical resistance anymore. It's a perfect conductor. And this would be really important because obviously at the moment we lose loads of energy kind of transporting electricity from the power station to where we need it around us, and it gets lost in the wires. If we could have a superconductor, you wouldn't lose that. And the other thing is, If we could have really good conductors like this, we could make excellent batteries that would hold the charge for really long periods of time. And that's really important in this kind of world where we've got trouble with energy. So that's why there's lots of research into this.
Thank you. This is Science Rocks.
Tell you a bit about what we've done with our films. In just 2.5 years, we've made over 100 films on topics as diverse as photosynthesis, radioactivity, moulds and psychology. Our films are typically 3 to 4 minutes long, which is topic specific. We keep them short, crammed with full important facts and try to keep them fun. Every year we enter film competitions with organisations such as the National Physical Laboratory. In the past we've had some great success. This film won Best Presentation Film at the NPL School Science Film Competition.
What is the difference between fuel and energy? Fuel is a substance like oil. Energy is locked in its chemical bonds and is released when the bonds are broken. Today we are going to look at the energy released when hydrogen and oxygen combine to make water. If this was an uncontrolled reaction, there would be an explosion or pop, but we are going to do a controlled reaction, so no pop. Hydrogen and oxygen gas are kept in separate tanks. The gases are fed into the fuel cell, where the two gases are separated by a membrane. This fuel cell has an anode, a cathode, and an electrolyte. At the anode, hydrogen gas becomes hydrogen ions and diffuses through the membrane. At the cathode, the H+ reacts with oxygen and gains electrons to produce water. This happens because electrons move from the anode to the cathode, creating an electric current. Water can be converted back into its component gases. This is electrolysis, but this process requires energy. So that's the science, and here's the demonstration. You can see the two gas tanks, one containing hydrogen and one containing oxygen. All wired up and ready to go. Time to test it on our Mars simulator. So there you have it. Hydrogen and oxygen are fuels which combine to release energy. Chemical energy is released and electric current is created, and this provides the usable energy to move our car on Mars. This is Science Rocks.
Topics are based on the GCSE syllabus, and we are gradually covering all areas of biology, chemistry, physics and psychology. We try to adopt a different style for each film just to keep it interesting. We have been out on location to a vineyard in Dorking and a river in Abenjahammer. We sometimes use a green screen to film at our house, and we also film when we visit laboratories and universities. There are plenty of science film sites on the internet, but most of these films are too long and a bit boring. We want to make films by teenagers for teenagers. We know we are on track because it is our films that have won awards and our whole site. They have won the following awards. So, what can Science Rocks do for you? It is a free resource crammed with GCSE specific films. They are very topic specific. Take photosynthesis as an example. We broke that down into 4 distinct sections so that you can use one film at a time as part of your lessons. Our interviews show that science is a great career opportunity and is lots of fun. You can follow us on Facebook and Twitter, subscribe to our YouTube channel, and of course there is our website. We have had feedback from around the world confirming that our films have been used in a variety of situations, including science-themed birthday parties and teaching at various levels. 2 UK-based educational charities have endorsed our films and tell their subscribers to use our films for revision. But most of all, we want people to be inspired to have fun. So we'd like to show you one last film which we made in collaboration with our school. It won the overall award at the MPL Science Film Competition in 2014. Making it was a lot of fun. Before we do, we'd like to say thank you. This is Science Rocks.
Those poor people left in the dark. It would have been very difficult without modern batteries to power their torches. But they could have used their limes.
What do you mean? Are you talking about limelight?
No, limelight was used in Victorian theatres from burning calcium oxide. It gave things an orangey glow.
We're going to look at how to get light out of limes. Firstly, we need some lime juice. Let's get juicing.
Here are the limes.
Once we have enough lime juice, we can fill up these 4 tubes to make our lime battery. This is how it works. Let's start with our 4 tubes of lime juice. This is the electrolyte. Now we can put zinc wires into each tube and then add the copper wires. This is the LED, and then finally we can connect the circuit. The electrons will move around the circuit and light up the LED.
Electrons move across the electrolyte and through the circuit from the anode to the cathode. They then move through the circuit, and that's how the LED lights up.
Mwahaha!
Wow, that's brilliant!
So what you're saying is that if we go back to the party in the old film, they could have used the limes to provide light?
Yes, as long as they had copper, zinc, wires, crocodile clips and an LED.
And plenty of lime juice.